Today we're going to touch on a topic very near and dear to my heart. You'll see it's a topic also near and dear to Dr. Neil deGrasse Tyson, NDT's heart, as we end this presentation. He's asked in a Q&A session a question. I don't think the person was prepared for the emotional response. But here's Red and Rover, great NASA enthusiasts themselves. Dear NASA, when can I apply to the astronaut program? Sincerely, Red, age 10. Dear Red, thank you for your interest. You can apply soon after you stop growing. Otherwise, you will cost the taxpayers millions in spacesuits and moon boots. You gotta love Red's tenacity. What you doing, says Rover. Writing to NASA to tell them how you want to explore the cosmos when you grow up? Nope. I want to do it now. Dear NASA, my current size and weight would help keep fuel costs down. Alright, here's a question for you to consider. Which of the following would you select in consideration of money to be spent on a space exploration mission, a satellite, a space telescope, whatever it might be? Would you consider paying A, $865 million right off the bat? Would you pay B, just 20 cents a year for a period of 10 years? Or C, neither option. They're both too extreme. We'll revisit that towards the end of our presentation. On page 32 of your notebook, you'll find the United States of America federal budget. Those of you who have graduated from Astronomy the Universe, this is the only repeat activity between the two courses, and it's essential, vital in both of the courses. So I doubt you have your Universe notebook handy with you. Be shocked and impressed if you do. Nor have you probably likely memorized the numbers. So a nice refresher activity for you. So the United States federal budget, we have three columns. We have the what do you think our government spends? What would your government spend? What does the government actually spend? I want you to take some time and seriously consider each of these facets. So first of all, we're going to give you some time to think about what do you think our government spends on these different categories? Now, I've certainly not listed all the categories. The stack of papers you would need to print out for all the different departments, agencies, administrations would just be incredibly thick. So I've taken some of the major highlights from a budget. Education, certainly aware of what education is. Energy and environment. Food and agriculture. Housing and community, so community within the housing, setting aside places for community parks, community areas, centers. Interest on the debt. International affairs, so when you see crises that happen around the world, maybe weather related, and we send aid in the form of money, it's going to come out of this area. When our top secretaries of state or president visit other countries, they generally take and bring them a gift, and that money is going to come out of the international affairs. Medicare and health, these are always topics of conversation and debates in election years. The military, that's going to include Homeland Security post 2001 with September 11th, tragedy there. So military and Homeland Security. Science, this includes medical research within science, so it wouldn't be health in here. This is medical science research, be part of this science. Social Security, unemployment and labor, another hot topic in election years. Transportation, so things like your federal highways, your interstates, maintaining those, building new ones, expanding. And veterans benefits, benefits paid to military personnel who have given their entire careers and have retired from military service, or rather tragically, someone who as you go into the military, you are signing your life away. You're writing a blank check for your country. And unfortunately, sometimes you do lose your life. And the military member who passes their spouse, their immediate family, is given a check. And there's absolutely no amount of money that would replace or take the place of the lost family member. But it's a amount of money so that the surviving family members can continue to live and function for several years. And again, the money is absolutely minuscule in comparison to what someone would be willing to pay to bring their loved one back to them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 categories. So the dozen here. And I think this comes from 2015. The federal budget was set aside for $3 8/10 trillion. It's a little easier if you think of $1 and think about, okay, for every tax dollar, how many pennies go towards education? How many pennies go to science? Now you're going to distribute the money between the 12 categories, and you're going to think about how our government spends that money. After you've put some thought into that, you then become the President of the United States, and you get to, should have moved the arrow over here, you get to establish, okay, you're the president, you're the one in charge, you're going to submit your budget proposal to Congress, and you can't just take the $1, or you can call it 100%. You just can't take the $1 and divide it into 12 pieces and write that number down in each of these columns. You have to divvy the money up. Some things are definitely going to require more money than others, and you have to make those decisions, submit your plan to Congress, and defend why you have decided to give one organization, agency, or administration more or less money than another. And you can't put 0 for interest on the debt. You actually are given information from the federal chairman of the reserves of what is the absolute minimum by law that you have to pay on the interest on the debt. So we'll let you decide that for now. You can't pay 0, though. You have to put something here. So your task at hand, fill out what do you think our government is spending in these categories. And then you have the power. What would you propose and submit to Congress and be willing to defend your choices and decisions? After you have put those 2 columns in, we will go over this final column of what does our government spend. So we'll set aside some time for that. There's 12 here. That's 24. You probably won't take a minute per, so cut that time in half of 12 minutes. Let's give you 15 minutes to work through and think through this. Important tip for you, if you're using the 100% or 100 penny method, make sure this column adds up to 100. Make sure this column adds up to 100. So we'll check back with you in 15 minutes. So let's say you've submitted to Congress your proposal. It's unheard of that Congress would initially pass without any adjustment. So to try and simulate the you gotta go back and rework and make tough decisions call, we're going to tell you what you must put for interest on the debt. And then you have the very difficult challenge of trying to say, okay, if you did not put enough here, who are you going to take away from? And with the interest on the debt, our government actually is required to pay just shy of 6 pennies or 6% of the budget. So you need to change this to 5.97, or you can put 6, but one of those 2 must go in there. If you did something less than 6, you've got the fun decision of trying to figure out who to take money from. If you did more than 6, you can leave this the way it is, or you could legally go ahead and pay less on the debt if you chose to and add it to other departments. So we'll check back with you in about 4 minutes of time for you to make your adjustments. If you don't need to make your adjustments, think about why you made your selection for the highest to receive and which is your lowest and why you made it the highest priority and the lowest priority out of the 12. You thinking about running for president? All right, so let's actually go through and look at what does our government actually spend here in the United States. So this is the federal budget. Imagine that the budget is $1 or how much you're paying on each incoming tax dollar. So we've already mentioned the 5 and 97 hundredths. All right, education. The education is just under 3%. You can see why we're often insisting more be put towards education, certainly as an educator myself. Energy and the environment. So renewable energy resources is actually something that is considered in the science budget for ways of reducing fossil fuel consumption, use. This energy and environment is more of kind of maintaining and providing for our national parks, things of that nature in terms of environment on that side of it. Or at least that's where I've grouped it in here in our example. That is going to be just barely over 1 penny on every tax dollar. Food and agriculture. Agriculture is so essential. If you can't grow it, it's got to be mined. And so agriculture, just tremendously important to any civilization. 3.5% or 3.5 pennies of every collected tax dollar. Housing and community, making sure we don't have homeless folks in our country, making sure we have good, safe communities. 1 6/10 of a penny of 100 pennies. International affairs, offering aid to other countries, keeping friends. 1 31 hundredths. Medicaid and health. I think you'll see here why so many presidential and even governor elections are so focused on Medicare and health. It's over 27% of our budget. So huge, huge topics of discussion of how things will be adjusted, Medicare and health services in our country. Military, about 16%, so a little less than 16%, 15 and 88 hundredths of a percent. Science. NASA is a part of science. We'll take a closer look how much of the science budget NASA receives. And science receives less than a penny, just over 3/4 of a penny. And remember, this is medical research, energy research, and less than a penny. So I guess I shouldn't gripe too much about education. Social Security, unemployment, and labor. Another substantial topic in debates, elections, and that's because it's 33%, 33.25% of our budget. Transportation, keep the highway or the interstates running and making new and keeping that infrastructure. 2 22 hundredths of a percent. And veterans benefits, 4 19 hundredths of a percent. So very interesting in what we have with our government spending. If we were to look at this in a pie graph, this was the 2015 budget that I was using. And so these are the two big areas of conversation in debates. Military isn't so much a debate as it has been in decades and years past. And here's the rest sliced up. So if the U.S. federal budget were broken up through representing a dollar, we know that science gets less than a penny. They get about 3/4 of a penny, 78 hundredths of the dollar. The amount that NASA receives is less than a half penny, just less than a half penny. And it's just mind-blowing to me. I mean, my obvious and clear bias towards NASA set aside, just on the pure fact alone that the information and the data, the things that are gained from NASA, is open to the public. It's the way the Congressional Act was written in October 1958, or enacted in October 1958. That the patents and things from products developed from NASA would be able to have commercial gains provided. And this is why very early on in the trimester, one of the very first things you do in this class is research these space technology spin-offs. And you had great submissions this trimester of things that piqued your interest. And it's just absolutely astounding how many things come from space exploration. You virtually, you live in a world where you essentially can't touch and interact with something that didn't have a direct result of space travel exploration associated with it. One of the things that came about from the Apollo program was to shrinkify, to make things smaller. Instead of having the computers that filled up the entire room, we need to downsize so that they can fit into these rockets, and other things downsize to fit into rockets. It's just incredible that the many of things that we have come from this mindset of being able to travel farther and, reduce the cost of fuel by making things less massive. The transistor in our electrical components, that is a direct result of the Apollo space program and efforts to get us to the moon. And so much of today's electronic equipment having transistor technology. It's just incredible, just staggering how many things in our daily lives are a direct result of space exploration. If we look at a comparison of NASA budget with defense, military defense budgets, 1958 when NASA began, all the way up to 1970, we see a significant increase for NASA when we have less than 1/10, up to the golden era, 5.5% of the federal budget, just completely unheard of today. And of course, this is politically driven. This is in response to President Kennedy announcing that we would land a person on the moon before the end of the decade of 1960s. And then, of course, we make our grand political statement, and the interest from the general public declines, and Congress consequently votes to spend less and less on space exploration. Here it's the end of the Cold War, and so an enormous amount of the budget, over half the budget, is going for military. There's, of course, your nuclear arms race. And just as NASA had some heydays, there were some golden days. Now, that's not necessarily a positive thought, that we need to defend the country to such a great extent that these were golden days in the military defense spending. But this is a very powerful graph here, where you look at the 2011 U.S. science budget. And so if this were a whole penny, you see that, science gets, or this is the 3/4 of a penny. You see this light green sliver is what NASA gets. The National Science Foundation, so grants from the government to be provided to scientists to do their research. This right here in comparison is the 2011 U.S. military budget. Homeland Security included in there, veteran services in here. So 2011 science budget, with this little sliver being NASA, the 2011 U.S. military budget, and then this is just the one that really needs to be understood by more of our population, especially voting citizens in the United States. This is the total 50-year combined budget for NASA since its inception in 1958. It is still less than this 1 year of military spending, which is why I'll show you a clip not too far away of what would it be like if NASA had a budget comparable to what the U.S. military received. Very somber thought here. For the same amount of money we spent on the Iraq War, we could send an Apollo mission every 2 weeks. Think about that, 41 billion liters of fuel per Saturn V rocket launch. Now, is the U.S. any different than in the worldwide perspective of space budgets and military budgets? A real quick glance look here. The worldwide military budget, about $2 trillion, and the worldwide space budget, $38 billion. About those budget cuts. No one ever visits anymore. It's true. There's just no money, and sadly, because there's no political interest by many constituents. I mentioned what would it be like if the government had, or NASA had the budget of the military, and here's a 2 or 3 minute clip kind of doing a dream wish list of spending.
They sent humans to walk on the moon, flew by every single planet in our solar system, and delivered the first residents to the International Space Station.
Absolutely not.
What else could NASA have done if it had a bigger budget? Say, the budget of the US military? How close would we be to colonizing Mars? Would you be spending your vacation on the moon? What about visiting other solar systems? This is What If, and here's what would happen if NASA had the US military's budget.
Oh, to dream.
In 1969, NASA spent over $25 billion, or about $170 billion in today's money, so that the whole world could see this. But once a small step for man became one giant leap for mankind, the budget of the American-led space agency started shrinking. Today, NASA gets less than $20 billion annually to explore and colonize what's out there. Is that enough for humanity's ambitions? Not if you plan on buying a piece of land on the moon. What if, due to a printing error in the federal budget, all the money destined for the US military went to the space agency instead?
To the space administration,
yes.
yes.
$600 billion pay for? Here's the International Space Station, the largest artificial satellite that's ever orbited Earth. Over 200 people have lived and worked here since it launched in 1998, but it may be defunded as of 2024.
Oh, there we go.
And then no one's going to set foot on it. With another $100 billion, NASA could afford to keep doing the research on the ISS for at least another 20 years.
Astronauts who
a
need
military-sized budget would cover that. Not only would it allow the space station to remain up and running, but it would also allow them to send more astronauts. And there'd still be enough money left over for NASA's biggest ongoing projects. Developing the space launch system that would carry us to the moon and deep space? Not a problem. And then there's Mars. Together with SpaceX, NASA could restore the uncrewed Red Dragon mission that would mark the beginning of Mars colonization.
I fully support a mission called Red Dragon.
Sending the first humans to Mars would cost NASA around $450 billion. With $600 billion of annual funding, a crewed mission to the Red Planet would become NASA's next Apollo very quickly. We'd build a human colony on the moon, turning it into a base for our trips into deep space. It would also serve as a blueprint for Mars colonization. We'd move up the launch date on the Europa Clipper, a mission to Jupiter's smallest moon in search of signs of alien life in the oceans of liquid water beneath its icy shell.
Maybe
Europa would become our next destination for the crewed missions. Just imagine. Regular commercial spaceflight. Uncrewed missions to other solar systems. Increasing biological and physiological studies to figure out how humans could survive away from Earth. Wouldn't that be awesome?
Yeah.
What else do you think we could achieve with a military budget?
Great questions to consider. Mark Roper, who's a Utah university grad, not University of Utah, but a local yokel, if you will, from Utah. He was a rocket scientist at NASA for many years, and he's going to outline 5 essential reasons that we should explore space, giving NASA a bigger budget. Maybe. There he is.
Why should we spend money on NASA when we already have so many problems here on Earth? If somebody asked you this question, how would you answer? It's been nearly 5 years since I left, but I came back to NASA's Jet Propulsion Laboratory today to help answer this tough question. But before I even get to the 5 reasons I think we should spend money on NASA, I need to clear one thing up. What percentage of the US budget do you think goes to NASA? According to polls, most Americans think it's 20%. So it should come as no surprise that 1 in 4 Americans think that NASA's budget should be reduced. If you say the total budget represents $1 or 100 pennies, the truth is NASA gets less than
I used to have a display like that.
Penny. For comparison, 16% goes to the military, and 60%
Wilbur
goes
gets
to
millions of
social
dollars
programs
to show
like
his
Social
display.
Security, unemployment, Medicare, and healthcare.
I should dig
Okay,
mine
so
out.
with that as our foundation, let me give you 5 incredible things we get in return for that 0.5%, or less than $9 a year for most Americans.
$9 a year.
Just like some might ask, why should we spend time exploring space when we have so many problems here on Earth? Some of our ancestors probably asked, why should we waste time trying to figure out agriculture when we have so much work to do hunting and gathering? Or, why should we spend so much time messing around in boats when we have so many issues here on the land? And the answer to all 3 of these questions is the same. Reaching for new heights often creates new solutions and opportunities for people back on the ground. And I have some personal experience with this concept. As most of you guys know by now, I spent 7 of my 9 years here at NASA working on the Curiosity rover. In fact, some of my hardware is still working like a champ on the top deck of the rover, albeit a little dirtier since I touched it last. But for my last 2 years here, I worked on a much lesser known project called SMAP, and in some ways, I'm more proud of what it represents, because SMAP is a super complex Earth orbiting satellite. Here's how it works. Once it's in orbit, the antenna boom is deployed, and then this 20-foot gold mesh reflector origamis out like one of those Hoberman sphere toys. And then the whole thing starts freaking spinning at 15 RPM. And it's using a radiometer that can see through the clouds to measure the soil moisture levels on Earth. This is important because soil moisture is one of the key vital signs of the planet. By measuring the moisture levels in the soil, it allows you to predict droughts, monitor floods, and even predict crop yields for a given year. And because the antenna spins around like that, you're able to measure all the soil on Earth every 2 to 3 days. So I left before it actually launched in 2015. So the reason I am here today is to follow up with some SMAP research scientists to see how things turned out.
I've been to many countries in Africa. People know about SMAP, and the national government of those countries are trying to use it, especially for drought, especially for crop monitoring. The NASA have a data access policy of making it free for everybody. There are 3 major cereal crops on the earth: wheat, rice, and corn. We can forecast these 3 major crops, so 70-80% of forecast you can do the crop yield of the whole world.
What Narendra is saying here is remarkable to me, and it sums up my first point perfectly. SMAP costs $900 million. Africa is the continent with the most extreme poverty today. I did the math, and for $900 million, you could feed all of Africa for less than a day. But instead, we invested in research and technology, which empowers them to better help themselves, increasing the amount of food they can make on their own for decades, as opposed to a one-time fleeting handout. Of the 37 missions currently running at JPL, I think it's so cool that about half are studying and helping Earth just like SMAP. This is a fancy way of saying we should be doing everything within our power to make sure that nothing catastrophically bad happens to us. Hollywood got this right when they said that a large asteroid impact would be really bad news. Now, the chances of this happening are small, but the potential consequences are so large, just ask these guys, it makes sense to take it seriously. NASA has already put an asteroid early warning detection system in place, and in October 2022, for the first time ever, they will test ramming a spacecraft into an asteroid to see if you can deflect it off course with a mission called DART. But perhaps an even bigger threat to humans are humans. One of the goals of all of the rovers that we sent to Mars is to gather data on what it would take for humans to live there. Establishing a permanent human outpost on Mars would serve sort of like a backup hard drive for your computer, in case something catastrophically bad happened here on Earth. America's first satellite was built here at JPL, and now satellites make it so we can get GPS driving directions on our phone, or get TV beamed down to us from space, or predict the path of hurricanes with much greater accuracy. The word pixel and the concept of the first digital camera was also invented at JPL in the 1960s when an engineer was trying to solve how to get pictures of the planets and send them back to Earth. In fact, there are nearly 2,000 NASA technology spin-offs. We don't know what we don't know. And so expecting NASA to justify its funding by predicting all the amazing things it will discover would be like expecting Christopher Columbus, when he was lobbying Queen Isabella for ships, to predict the polio vaccine or Netflix. Of the $18 billion that NASA gets, it's not like they're just putting that money on a rocket and launching it into space. The majority of that money goes towards the salaries of tens of thousands of some of America's most skilled workers. And one of the counter arguments here is, yeah, but why do we need the government to fund these programs? Why not let private companies do the innovating? Private space companies like SpaceX or Blue Origin are awesome, and they play an important role, but they're incentivized to pursue technologies that will give them a return on investment, like space tourism or asteroid mining or launching satellites for other organizations. There's just no incentive for a private company to invest in tracking and deflecting asteroids, or investing in Earth science missions like SMAP, and then making the data available for free to anyone who needs it. So to recap, for that less than half a penny from a dollar investment in NASA, not only do we improve life on Earth through projects like SMAP and protect ourselves against really catastrophic events and discover other incredible technologies to improve our lives along the way, but the money to make all that happen goes back into growing the economy through the salaries of all the smart people doing the work. And my fifth and final reason why we should spend money on NASA, even when we still have unsolved problems here on Earth, is perhaps the most important, even if less concrete. I think it's captured best by what some call the most important picture ever taken. What you see here is the result of a 10-day exposure image from the Hubble Deep Space Telescope. With the exception of these three dots, which are single stars, every speck, smudge, and spiral you see in this image is a galaxy with hundreds of billions of stars, just like our own Milky Way galaxy. Most remarkably, the field of view captured here is the darkest part of the night sky, the size of Roosevelt's eye on a dime, held at arm's length. We send men to the moon, and orbiters to Saturn, and rovers to Mars, not necessarily because there's some financial incentive or some quick payoff we're looking to exploit, but because as humans, there are fundamental burning questions we yearn to answer. The first person to set foot on Mars is alive right now. They could be in junior high or high school. He or she could be watching this video right now. It could be you. I feel that our continued exploration of space in all its forms fills me with hope and inspires me to reach higher and makes me a better person.
And the next clip is the one I mentioned at the beginning of the presentation, where NDT was giving a presentation and opening it up for questions from the audience, and I think the gentleman who asked the question got more than he bargained from. And here we go.
My question for you is, you had the opportunity to serve on the Moon, Mars, and Beyond Commission in 2004. Would you like to care to discuss the recent changes to the nation's space program?
Let's start out by asking, what is NASA to us as a nation? What is NASA? If I had a nickel for every time someone said, why are we spending money up there when we have problems down here? And I think about, if you're only looking down, one day the asteroid's coming, you know, but I'm just looking down here, I'm fine. You know, at some point, you gotta look up.
Astronomy is looking up.
It promotes the commercial access to low Earth orbit, a couple of hundred miles up, where the space station and space shuttle goes. Low Earth orbit is no longer a space frontier. The original Space Act from 1958 says NASA needs to advance a space frontier. Low Earth orbit is to boldly go where hundreds have gone before. It's not a frontier anymore. Move NASA to the next step. What does the program allow? It says we're not going to the moon anymore. Maybe we'll go to Mars one day. I don't know when, but let's work on some technology that might enable that someday. That worries me, because without a plan to go somewhere outside of low Earth orbit, we've got no force operating on the educational pipeline of America. NASA, as best as I can judge, is a force of nature like none other. I have never seen, with all due respect to other federal agencies, I have never seen 8th graders sit up in their chair and say, when I grow up, I want to be an NSF researcher or an NIH researcher. With all due respect to those agencies, they do important scientific work, but they are unknown and invisible at the age where people choose what they want to be when they grow up. And so what worries me is that if you take away the MAN program, a program which, if you advance frontiers, heroes are made, okay? There's a force operating on the educational pipeline that will stimulate the formation of scientists, engineers, mathematicians, and technologists, the STEM research fields. You birth these people into society. They're the ones that make tomorrow come. The foundations of economies in the 21st century, will issue forth from investments we make in science and technology. That we've known since the dawn of the Industrial Revolution. We have known that those nations that embrace those investments are those that lead the world. America is fading right now. Fading. By the way, how much does NASA cost? It's a half a penny on a dollar. Did you know that? The people who say, why are we spending money up here, down? I ask them, how much do you think we're spending? They say 5 cents, 10 cents on a dollar. It's a half a penny. A half a penny. That buys the space station, the space shuttles, all the NASA centers, the rovers, the Hubble telescope, all the astronauts, all of that. Nobody's dreaming about tomorrow anymore. NASA knows how to dream about tomorrow. If the funding can accommodate it, the funding can empower it, the funding can enable it. Yeah, you need good teachers, no doubt about it, but the teachers come and go, because I go to the next grade. Teachers can help light a flame, but I need something to keep the flame fanned. It's about the effect of NASA on who and what we are as a nation, what we have been as a nation, perhaps for a while there took it for granted. I see the most powerful particle accelerators in some other country. The fastest trains are built by Germany and are running in China right now. I see our infrastructure collapsing, no one dreaming about tomorrow, and everybody thinks they can put a Band-Aid on one problem or another. The most powerful agency on the dreams of a nation is currently underfunded to do what it needs to be doing, and that's making dreams come true. And at a half a penny on a dollar, how much would you pay for the universe?
What a terrific question. Your A, B, and C decision from earlier. This is political speak right here. So this is the amount of money that was spent in the 70s for a Voyager spacecraft mission. It cost the taxpayers 20 cents a year for 10 years, which back then turned out to be $865 million. So it's the same. This one seems extravagantly higher, and this is why politicians tend to talk in billions and millions and trillions, rather than breaking down the cost, recognizing that NASA gets less than half a penny for every taxed dollar. So have you wrap up page 32 and spend some time of what most surprised you or did you find most interesting in learning about the federal budget? Try and fill up the space here. Don't just write your words larger, but give some careful and thoughtful insight into what you learned about the federal budget.